In this video, I'm going to introduce the concept of marginal profit. So profit is what remains from revenue after your costs have been subtracted out. So if you wanted to come up with an equation, which we usually do, we could say that profit is equal to revenue minus cost, or a profit function would be equal to a revenue function minus the cost function. And that's the way that we want to look at this from a mathematical point of view. So in the first example, let's come up with a profit function for this particular situation. So take a second, read the example. Okay, so since the profit function is going to be equal to the revenue function minus the cost function, to come up with a profit function, we simply take the revenue function, 22x plus 12x cubed, and subtract from that the cost function, which is 13.7x squared minus 3407. And that would be our profit function. Let's clean it up a little bit. There are no similar terms to add, but I'm still going to put this in descending order of the powers of x. So 12x cubed minus 13.7x squared. And then we would have a plus 22x and a plus 3407. Don't forget to distribute that negative through to make that a plus. Well, to answer the first question, what is the profit at 11 spectrometers? All we have to do is evaluate this in Desmos at 11. And when you do that, you're going to end up with 17,963.3. So when 11 of these mass spectrometers are sold, this is what the profit would be. Now, the second part of this is marginal profit. Well, just like with marginal cost or marginal revenue, marginal profit is the derivative of the cost function. So marginal profit is the derivative of the profit function, rather. So the marginal profit function would look something like this: 36x squared minus 17.4x plus 22. That was simply the derivative of the profit function. And then to find the marginal profit at 11, we simply evaluate this in Desmos at 11, and we would end up with 4,076.6. That means when 11 spectrometers are sold and you sell one more, that would be the 12th one, the additional profit would be $4,076.60. All right, so that is marginal profit and profit. So the important things to get out of this are the relationship between profit, revenue, and costs. And then, of course, marginal profit being the derivative of profit. The next question is just a little bit different. And this is asking about maximizing profit. This question, we want to maximize profit. So we took a look at something similar to this in the last video on costs. And what we learned there is that profit will be maximized where the marginal revenue function is equal to the marginal cost function. So we need to find the marginal revenue function. And so we're given the marginal revenue function here. We are given the margin of the cost function here, revenue function, cost function. We need to find the marginal revenue. So the marginal revenue function is 0.006x plus 0.8. And the marginal cost function, the derivative of the cost function, is simply going to be 20. And so to answer this question, we have to set those two equal to each other. All right, so we need to find out where 0.006x plus 0.8 is equal to 20. That would be putting marginal revenue here and marginal cost there, setting them equal to each other. Well, just doing a little bit of algebra on this, we will end up with 0.006x is equal to 19.2, or x is equal to 19.2 divided by 0.006, or x being equal to 3,200. So what does this mean? What is this number? This is the number that will maximize profit. X represents the quantity of pounds sold, and that was right up above here. X represents the number of pounds being sold. So that means when Skagway Coffee Company sells 3,200 pounds of coffee, it will be maximizing its profits according to this particular revenue function and this particular cost function. All right, that's it for this video.